Hi guys, I'm Ryan with Arctic Oven. I'm part of the marketing department. I'm here with Abel, part of product development, and we're here at our Palmer sewing facility and also the location where we do a lot of product testing on our tents. We're going to actually talk through one of our product tests that we did outside this fall. It was a prop blast, and we're going to talk through that and break down what happened when we did that test. All right, Abel, tell us a little bit about the plane that you're flying here and the plane that we used to do the experiment, the test.
Yeah, so the plane that we're using in the test, it's 1952 Cessna 170B. It's got a stock C145, makes about 145 horsepower. It's got an 82-inch prop on it. It's a climb prop. Cruises about 100 miles an hour. And in this first test, we were just kind of getting our feet wet and seeing what the tent can do. And we started out in the neighborhood of somewhere between 70 and 80 miles an hour.
We have the tent set up. This is at our Palmer campus. This is a new Noonatak design. We made some modifications, changed some of the high wind tie-out points, changed the halo construction, the spider construction, and the pole. Or we made some changes, not always construction, but there are changes to it.
Yep.
Then can you tell us about the one tie-out that we're seeing that has a yellow tie-out?
Sure, so what you're seeing here is, this test is designed to see how the tent itself interacts with wind from one direction. And in this case, the one tie-out that you see is it's a yellow strap, and it identifies which tie-out is going to see the most load. And we use this yellow tie-out, or this yellow tie-out line, specifically because we didn't want to have any other inconsistencies in the test. We wanted to be able to test just the tent and keep everything else consistent. So we ensured this by using a strap that was way stronger than what was ever going to be close to the breaking strength of the strap itself.
Right, so the strap is stronger than your typical P-cord, paracord, on purpose, because we're trying to test the strength of the
tent.
tie-out.
Yeah, we're trying to test the strength of the tent and the tie-out, not the strap. The strap's rated for somewhere in the neighborhood of 2,500 to 3,000 pounds working load, and your standard, paracord guy out might be good for 600.
Okay, and so
most.
I just want to preface, we went out there with full intent of trying to actually put this through a really rigorous test and just destroy the tent. We expected to see rips, tears, or collapse, but we're trying to actually do that so we understand how to make it stronger. That was the point of this test. So I'm going to play it and watch what happens on the first run of this test. Okay, so you're getting in position here.
Yep. Plane comes out, it's about 15 feet in front of the tent. And once everyone's set up and ready to go, we'll throttle up to somewhere in the neighborhood of 21 to 2200 RPM, which should give us in the neighborhood of that 65 to 70 mile an hour wind. And as you can see, the tent is staked out in dirt. It is using military stakes, our large heavy-duty stakes. Again, trying to make sure that we keep the test as consistent and standard as possible.
Yeah.
So we don't have issues with stakes pulling out of the ground.
Okay, so throttling up a lot here.
Yeah.
Yeah. And then you're going to get a look at the inside in a second too. Mm-hmm. So we have GoPros on the inside.
And we were convenient enough to have some debris on the ground to give it a real world scenario here. We got some throwing rocks and sticks and things.
Right. So now this is on the inside. We have a camera strapped to a carbon fiber center pole that you've been doing tests on as well too. So, and what were you trying to accomplish in here? Why did you have that view?
So the camera in this specific instance was oriented such that it's looking up at the halo on the tent. And as people will find out when they purchase these tents or when they look at them on the showroom floor, you'll notice they don't have a spider anymore. And this test was specifically designed to see how the tent reacts in high wind without the use of a spider, and instead the halo is incorporated into the actual body of the tent.
The first one, we didn't see any damage sustained. There's no issues, right?
None.
Okay. So we said, okay, let's ratchet it up a notch here. Let's go a little bit stronger.
And this is in our second test where we're going up to full power. And full power is just shy of 2,400 RPM, which should give us over 100 mile an hour wind. And as you can see, it's not a pleasant environment to be in.
Yeah.
The tent's taken a real beating. And what we ended up seeing in this test was the high wind tie-out on the outside failed. It was a first failure mode in the high wind. And and we've since adjusted the design and increased its strength, so this shouldn't happen in the field.
Okay, what about materials and seams? Any relation to failure or changes that we made to improve that, or was it?
The failure that we saw in here was specifically on our vinyl tie-out loop. So the loop it's round and has a cutout, and rather than using webbing or something, we tried to conserve weight, make it simpler on the sewers to manufacture by just using a cutout and having your high wind on a piece of vinyl. That the vinyl failed. It was just the material. It wasn't the seam. So we in this case ensured that our seams were amply strong enough to support the wind.
Right.
And in our new design, we've changed it so it now has a combination of a vinyl and a piece of poly webbing that is sewn on with a box stitch, which should create a stronger tie out on those specific sides.
Right. So again, we're testing it for the sake of weight, and to see where we might need to scale up or down.
Exactly. Yeah.
Okay. So at this point, we're going to see the tent with the tie out has been broken. So the yellow strap that we saw at the beginning is no longer there. We knew that we'd see failure at this point because we wanted to just see what the tent would do when we did it without having that tie out there. And it also just shows why we have the tie outs and how important it is to actually use the tie outs in high wind, because they actually will work.
They support the tent in a real crazy way.
And the tent basically act as a sail, which most tents will do this regardless
of how it's tied out.
Maybe a geodesic style dome like the Arctic Oven Igloo may be able to manage that wind, but let's take a look at that.
And again, this is pushing over 100 miles an hour of wind without the center tie outs. And as you can see there, what it ended up doing was ripping right from one of the corners on the stake out at the bottom. And looking at the fabric and looking at the failure mode, it did appear that something punctured the bottom of the tent. And then from there, a tear propagated around the side of the tent, along the bottom hemmed seam where all of the tie outs in the tent are. And again, it was a catastrophic failure, but we expected and we wanted to see it. We wanted to be able to see what we could say the tent's strength is. And given the right circumstances, the Nunatech can be used in high wind, just like any of our other Arctic ovens.
You'll see things that are inside the tent. That was actually just
another tent.
Yeah, another tent. We were just putting it there to get it out of the wind. So that's not actually part of the tent. That's just, we were storing stuff inside while we ran this test. We didn't remove it prior because we wanted to see what it would look like if you had gear inside there and how it would work. One thing we did find during this test was it actually ripped away from the stakes. You'll see that here in a second.
Yeah. If we go in close, you can see all of the stakes are sitting on the ground.
Right. So this shows the inside during the catastrophic failure, and then we'll get back to the stakes here.
But again, and this test also, I want to be clear, it was the purpose of demonstrating the strength of the tie out and how the tent interacted without the halo, or without the spider, excuse me. And as you could see in the video, the halo stayed stable throughout the entire test.
So the halo never failed.
No, the halo never failed, which proved our design. We were able to reduce weight by taking out the spider. It reduces complexity of setting the tent up, and then it reduced the chance of having a failure mode in the halo because it no longer has straps that can move around in high wind or in snow loading.
So overall, the test, we learned a lot. It was interesting to see the failure points, understand the strengths and weaknesses, and then we're just kind of looking at the debris field here. We use military stakes and HD nail stakes, it looks like. You can see that parts of the tent are still connected to, the webbing is still connected to the stakes.
Yeah, so the webbing is still connected to the stakes, and just like Ryan said, and then the fabric is connected to the webbing. And what you're seeing is propagation of a tear along a seam, which is expected, because as you poke holes in fabric, you create a weak spot for something to rip from.
Right.
But this just proves that the tie outs themselves are very strong in their connection to the tent body itself.
Right. So the tie outs are strong. The issue could be debris hitting the material, and that propagates the rip, which we did find an area where it started, and it was probably from a sharp rock or some other debris being blasted.
Which definitely highlights the importance of taking care of your tent and making sure that if you do find rips or tears in your tent due to sharp objects, to take care of them, because if you're going to be using your tent in extreme conditions, you don't want to give your tent an opportunity to fail at a weak point.
All right, we'll look at it fail one more time just to kind of close out with the pinnacle part of this whole video. Pretty interesting stuff.